Okay, so we're going to be learning about slopes and equations of lines today. Hopefully you guys have seen this before, this formula, finding slope. You guys remember how to do that? Rise over run, you take the y values of the points and subtract them. Then you take the x values of the points and subtract them, and you write it as a ratio or a fraction. It's rise over run, so that means the y's have to go on top, rise and y's and run. And then you have the x's on the bottom. What about horizontal lines? Remember, horizontal is flat like this. That has a slope of 0. You can think of it that way, as if you're trying to ski and you're just like standing here, you wouldn't go anywhere, so it has a slope of 0. And then vertical lines like this, straight up and down, it's a slope that's undefined. It doesn't really have a slope, right? So if you imagine skiing on this, right, you'd fall and die. That's usually the analogy they use. So you have your horizontal slope of 0, and then your vertical slope is undefined. We have 3 different types of equations of lines that you can use. You have slope-intercept, point slope, and standard form. This one you're not going to see very often, standard form, but the other 2 you will see often. When you guys hear y equals mx plus b, you hear that a lot, right? Yeah. And you use it a lot. The official name of that is slope-intercept form. Why do you think we call it slope-intercept form? Because it includes the y-intercept and the slope. So basically the name of the equation is what you need in order to write it. So in order to write the y equals mx plus b, you need to know m, which is the slope, and you need to know b, which is the intercept. So the name pretty much gives away everything you need. What do you think you would need for a point slope form? A point, a full point, not just an intercept, but just a random point somewhere on the line, and the slope. So as long as you have those 2 things, so m still represents the slope. I always have people asking why m, I don't know. M is the slope, and then they're going to give you some random point. It's not going to be an intercept, it's going to be some random point. You have x1 and y1 go into these positions within the equation. And then standard form, you can only find that if you have one of these 2 first, and you rearrange the terms. But you guys aren't going to be needing to worry about that very often. You may be given an equation in standard form, you need to kind of move it around, but you'll never be asked to write it in standard form. And I'll show you what I mean when we get to that. All right, parallel lines. Please. Thank you. Yes. All right, what do you guys know about the slopes of parallel lines? They're what? They are the same. So parallel lines have congruent or equal slopes. Whenever you guys are looking at lines and comparing the slopes, if they have the exact same slope, then they're going to be parallel. All vertical lines are parallel. That makes sense, right? All vertical lines are, they have the same slope, which is undefined, so they would never cross each other. Same thing for horizontal. They all have the same slope of 0, so they would never cross. So that's a little kind of tidbit you guys can use. If you have a vertical line, every other vertical line that exists is parallel to that. Same with horizontal. All right, so I have 2 activities here. I want you guys to look at these 2 lines and figure out whether they're slope or not. Or sorry, whether they're parallel or not. So when you look at them, you can't really tell visually, right? You can't and you shouldn't. What is something I can do to figure out whether they're parallel or not? What do we base that on? What do I need to know about the lines? Their slope. So we're going to go ahead and use the slope formula that's at the top of the page to find the slopes of our lines. So for this one, it has 2 points, and you do need 2 points to find the slope. What would my formula look like if I started plugging numbers in? Remember, you subtract the y's on top, so what would be on the top? 1 minus 4. If you guys are working from left to right, so I have 1 minus 4. y1 minus y2, and then what would be in the bottom? x1 minus x2. The y's go on the top, the x's go on the bottom, and you just subtract them. So this is showing work. Now we're going to simplify it. So what is 1 minus 4? And what is negative 3 minus 3? Okay. This is still not fully simplified. Maybe you guys give me a slope and needs to be in simplest terms for your fraction. So what do you think it would be? 1/2. That simplifies to 1/2. So the slope of our line is 1/2.
Would it be negative 1/2?
No, because the negatives cancel each other. What about the bottom line? What would my formula look like?
-5 minus -4.
Okay, what does that turn into if you do minus and negative? A plus. So it's -5 plus 4, because it's a double negative. And then, what's on the bottom?
0 minus
0 minus 2. Okay, so then I have -5 plus 4 leaves me with -1. And 0 minus 2 leaves me with, what does that simplify to? Positive 1/2 because the negative cancel. So if I ask you one more time, are these two lines parallel?
Yeah.
You would say yes. Because these slopes are the same.
So it's
Look at my fair son.
It's so pretty. Yes.
Alright, go ahead and try the next one on your own, please. Find the slope of the line on the left, find the slope of the line on the right, and tell me whether they're parallel. They'll all work.
Oh, no, it's just-
Wait, is it Y over X or X?
The y is straight on the top. Can anybody tell me what the slope of the line on the left, far left, what's the slope of that line? Was it -3? Or if you write it as a fraction, you can write it as -3/1. And then what about the one on the right?
-6.
Okay, or -6/1 if you want to write it as a fraction. So, would these lines be parallel? No, why not?
They're not equal.
What are not equal? The slopes are not equal. You guys may have noticed that when you guys have a coordinate plane, you can find the slope by counting as well.
That's what I
did the first one I counted.
I'm pretty confused. Why is it not, I got 1/3, 1/6.
Because it's rise over n. So you want to start at the lower point. You start at the lower point, you have to go up 3 and then over 1. You always do the.
So it's not like a graph if you go on the left, right? That's wrong. But the,
We'll see how it's falling from left to right. That tells you that it's negative. You could also start on this point and go down 3 and over 1, which just tells you that it's negative.
I think it's
Yeah, you always do the how much it's gone up or down. Yeah, it's the reverse of graphing a point. You have to think about the y first.
Okay, that's what I want to do.
Yeah, so when you guys have the points physically on a graph, you can count, but if they had given you not a graph, they just said this is a point and that's a point, you actually have to do the formula. Yes. Because it's sloping downwards. If it's falling from left to right, it's negative. So you go down 6 and over 1, because you're falling. Alright, questions on that? Pretty straightforward, right? Alright, now we're going to switch to writing equations. That's determining if they're parallel or not based on the slopes. Now we're going to assume that we have a parallel line and write the equation. So you're going to have directions like this. It says write the equation of the line that has a y-intercept of 5 and is parallel to the line provided. Okay? So remember, we have 3 different types of lines. We have point slope, slope intercept, and standard. They're not going to ask you to write it in standard. So you guys have to pick. Which form of the line do you think I need? The slope intercept or the point slope? Well, what two things do you need in order to write point slope form? You need a point and a slope. Did they give me a point, like an x and a y here? No, so I can't use point slope. I'm going to be using slope intercept. So I'm going to write that down, y equals mx plus b. Once you guys figure out which form to use, one of those two, write it down off in the corner so you have the formula written. Now we're going to analyze the directions. For this equation, I need to know the slope and I need to know the intercept. What have they told me? The intercept is 5, so that's a crucial piece of information. And then they said this line should be parallel to this one. Should be parallel to this one. So have they given me the slope? They didn't directly tell me what the slope is, like slope is blank. They said it should be parallel to this line. So what would the slope be? It would be the same as the slope that they have provided. Remember, parallel lines have the same slope. So if they give you one equation with a slope, your equation you're about to write should have the exact same slope. You have y equals, then the slope is going to stay the same, so negative 1/2 x, and then what comes at the end? Plus 5. Very good. That's how you do these questions. Okay? What about the next one? It says write an equation of the line that passes through negative 1, 2, and is parallel to the line blah. It's given. Which form of equation do I want to use this time? They've given me a point, and they've indicated what my slope should be. So I should be using the point slope form. So we're going to write that over here. Y minus y1 is equal to m parentheses x minus. Yes, you do have to memorize this formula so you can use them. So all you're going to do is just plug stuff in. So the y1 and the x1 come from the point. The y and the x are going to remain variables, just like we have y and x up here. So the ones without the little subscripts, those stay as variables. So I have y minus, then I'm going to have to write down what the y value is from the point. What's the y value from the point? 2. I access this point right here. The 2 is the y value. So that goes in the place of y1. Then what's the slope supposed to be if this line needs to be parallel? 2/3, it stays the same. And then parentheses, my x remains a variable, but now I have to subtract the x value from the point. What's the x value from the point? So if I subtract a negative 1, plus. So you just write it like that, and you're good. So 2 different types, just need to read the question and the information provided to know which form to use, and you just start plugging stuff in.
Oh, we're not putting it into.
No, unless the directions tell you to. If they just tell you to write the equation, you can just leave it like this. If they specify which form of the equation, so if they write this, they give you a point and a slope, and then they specifically say write it in slope-intercept form, then you'd have to do more. You'd have to distribute the 2/3, add the 2, but the directions didn't say to use slope-intercept.
So I'm actually just like.
Well, you can if you want to. But if they don't specifically say to write it in that form and they give you a point, they expect it to look like that. Alright, so that's everybody okay with parallel? The idea of parallels?
Oh, I hate it.
Now we're going to talk about perpendicular. Okay? Perpendicular lines, what do you know about their slopes? Are they going to have the same slope or perpendicular? No. Do you guys remember what their relationship is?
Are they going to be flipped, and if it's positive, then it's negative, and negative, it's positive?
Yes. Do you know the official terminology? Reciprocal is part of it. Reciprocal means flip, but there's more to it than just flipping it. It's opposite reciprocal.
Oh, I think
Oops. Opposite reciprocal. So that means whatever number they give you, you're going to flip it and you're going to change the sign. Okay, so if we're going through here, if I start with 1/3, what would the opposite reciprocal be? Negative 3/1 or just negative 3. Usually we prefer to write slopes as a fraction so you can see the rise over run. So get into the habit of doing that. If it starts as negative 3/4, what would the opposite reciprocal be? Positive 4/3. Start as 1/5. Negative 5/1. And if it starts as negative 7. It would be 1 over 7. So remember, whenever you guys have a constant that's technically over 1, that's why it's important to think of slopes as fractions always, so you can see that reciprocal when you're flipping. All right, same activity we did last time, but with perpendicular lines now. So write the equation of a line that has a y-intercept of 5 and is perpendicular to that line. Which form of an equation of a line will I use? Slope-intercept or point-slope? Which one? The slope-intercept, and do you guys remember what that looks like without looking? Y equals mx plus b. How did I know I'm going to be using this form? Yeah, it didn't give you a point, it gave you an intercept specifically. So it says the y-intercept is 5. Now we're going to be doing perpendicular to that slope. So when I write my equation, y equals, what should I write as my slope? Should I leave it as -1/2? It should be positive 2 over 1. You don't have to write it as 2 over 1, you can write it as a 2 in writing the equation, that's fine with me. And then you have your x, and then how would I finish it? Plus 1. Good. So notice how I circled the word perpendicular. You guys need to make sure you're looking for that to see whether it's parallel or perpendicular so you know how to work with the slope. All right, what about the next one? Which form of an equation would I use? This is going to be point slope because they give you a point this time. All right, so I have a point, and I'm going to be perpendicular to this one. So my formula is y minus y1 equals m times x minus x. Okay, everybody ready? Y minus, everybody, y minus 2 equals, what would my perpendicular slope be? Negative 3 over 2 x plus 1. Okay? Is everybody good? Cool. Alright, on this page we're going to switch gears a little bit. So this time I'm giving you guys equations of 2 lines, and I want to know if they're perpendicular, parallel, or neither of those. Alright, if they're neither perpendicular nor parallel, do you guys know what they're called? Well, specifically. If they're not parallel and they're not exactly perpendicular, what do you just call those lines? We're not talking about lines. No? How do you describe lines that just cross like this? Those are angles, guys. They're not vertical.
Intercept.
There you go.
Yes. Yes. I remember it.
It's okay.
So lines are either parallel, perpendicular, so that they're intersecting at 90-degree angles, or they're just randomly intersecting. All right. So you guys can use the word neither because we're trying to see which type it is. But intersecting is the official name of lines that just cross each other randomly. All right. So the strategy is make sure that they are in this form. You need to make sure that both equations are in slope-intercept form so you can really easily spot the slope and compare them. So sometimes your equations are already in slope-intercept form, sometimes they're not. Oftentimes they're in standard forms. You have to solve for y to get it into slope-intercept form. Okay? So take a look at this one. Is this in slope-intercept form?
Yes.
Yes, it is. As long as the y is by itself and everything else is on the other side, you're good. What about this one?
Yes.
Okay, so they're both in slope-intercept form. I like to draw little check marks when I know that they're both the way that they're supposed to be written. Now we're going to take a look at the slope. I have a slope of 3 and a slope of -1/3.
That's perfect.
That's perpendicular. Does everybody agree? Yeah, so you're correct. These are perpendicular. Perpendicular because they are opposite reciprocals of one another. Okay? All right, next example, over to the right. Is this equation in slope-intercept form?
No.
Yes, it is in standard. What about the bottom one? Yes. All right, so I just have to do a little bit of work before I can answer this question. I'm going to have to take the first equation and solve for y. So that's in slope-intercept form. Okay? So that's why I have some work down here, so you guys can do that. What's the first first thing I would want to do to get y by itself. Add the x. Okay? So this equation would turn into 2y equals x plus 6. I'm going to move the 6 over so the x is where it's supposed to be in slope-intercept form. So I'm just going to push the 6 over and add the x in front of it. Now what? Divide by 2. Now, I'm going to split this up. I know you guys are used to when you divide by 2, you just divide the whole thing, like x plus 6 goes on the top, divided by 2 goes on the bottom. I don't want you guys to do that. I want you to divide each of them by 2 separately. So I would write it as x over 2 plus, and then what's 6 divided by 2? 3. Write it like this.
How does that work?
You also do 1 over 2x.
Yeah, you could also write it like this, which is actually more helpful.
Wait, do we have to do it like that?
Yes. Yes, you do. You can also write it like this because dividing something by 2 is the same thing as multiplying times 1/2. This is actually more useful in determining what the slope is.
I have a question. Can you put like x as 0 and solve? Because that's what I know. Like
X is 0?
yeah, so you have basically -1 times 0, which is 0. So x is not even there anymore.
No, the x needs to be there, or you don't have an equation. That's slope-intercept form.
But when
Don't-
you're solving,
don't
but when you're
change.
solving y.
We're rearranging the question so that it's solved for y. We're not actually trying to figure out what y is as a number. We're trying to solve the equation as an expression, not a number. So we're just shifting everything to the other side so y is by itself. So your equation should look like one of these bottom two. This one's better, the one on the right. Now let's take a look at the slopes. All right. What's the slope of our first line now? 1/2. What's the slope of the bottom line? -1/2. So what is the relationship? Are they parallel, perpendicular, or neither? It's neither. Why? They're just randomly intersecting, but why is this not parallel or perpendicular? They're not equal, so we can rule out parallel, but why not perpendicular? Because I see the negative.
Because it's not close.
Yeah.
That's why.
For perpendicular, you need two things, both the sign changes and the fraction flips. That's the biggest mistake that I've seen in the past. So I'm sure you guys are looking for both of those. All right, what about this one? Slope intercept form for both? We're both set up. What's the slope of the first one? What's the slope of the second one? What's the relationship? This is another one where they've done the reciprocal, but they didn't do the opposite, like changing sign. So it rules out perpendicular. You need both, change the sign and flips. So it'd be neither. Right? You guys see how we do that? Do I need to do another one with you, or do you guys think you can finish them on your own? Answer my question, please. You can finish them?
Yeah.
All right, go ahead and do the rest of them. guys finish, glance up, make sure you have the right answers.
I think you did that one wrong.
What's wrong? Choose your number.
100. The one under the first one.
This one?
Yeah.
I got the last one wrong.
How's that wrong? It's good, yeah.
No, that's right. It's perpendicular.
You sure?
Yep.
I'm pretty sure she got
I think you are.
Yeah, I did the same thing with that one. I just read it wrong.
Wait, can you post this?
I read it wrong. It's perpendicular.
That's what you get.
I just
You should be like this.
Okay. -1/2 and 2 are opposite reciprocals of each other. -2/4 simplifies.
That's what got me for a second. I was like,
You better look, if you can simplify that fraction, you better.
that's what I was going to ask if you have to say.
Alright? So it's really, again, just a matter of making sure the lines are in slope-intercept form by solving. You should know how to do that from algebra. I'm not going to teach you how to do that, but you should know how to do that already. And then you look at the slopes and compare them. Okay? So you see that often where you get two equations, you have to figure out whether they're parallel, perpendicular, or neither. Alright, any questions on that? Cool. This last thing we're going to talk about is something that we often see on SOLs and district exams. So I want to make sure we take a look at this. So we have a wonky looking picture here that has a line and then a random point floating out in space. Okay? So what you guys are going to be doing for me is you're going to find points, other points that you could add on to this one right here. So you can draw a line that's both parallel to this or perpendicular.
Whichever one.
Well, we're going to do both. Okay? There are always multiple answers. So when we get closer to the SOL and the district exams, I'll make sure I show you. But oftentimes the way that you select your answer is you draw a point or select a point. That would help you create that parallel or perpendicular line. Right now we're just going to write them down. But there are multiple different answers. Right? Because see how on the line you have one, 2, you could do another one, keep going on forever. So you have a lot of different options you can choose. So we're going to find points that create parallel lines and perpendicular. In order to do that, what do you guys need to know first? Slope. They gave you one of the lines. We need to find the slope first, and then we're going to mimic that slope from the other point. So first, if we're looking for parallel, what is the slope of this line? You go up 3 and over 1. So the slope is 3 over 1. If I want another line that I'm about to draw to be parallel, what should its slope be? Okay, so let's imagine we're about to draw that line through this point right here. How could I find another point? Starting from here, you go up 3 and over 1. That's how you create a parallel line. It has the exact same slope. Remember on a graph, you can just count rise over run to get that slope to happen. So what is that point? -2, 5. Now, is that the only possibility? No. Why? You could also go down. You could go down 3 and over 1. You could do this point as well. You could keep going. You could go down another 3 and over 1. You could choose that one. Right? It's really up to you what direction you want to go in. But it needs to have that positive slope of 3 over 1. And you just pick any point that will do that. Okay? Now we're going to switch to perpendicular. What should the perpendicular slope be? Just opposite?
Should be -1.
It should be -1 over 3 is my perpendicular slope. So again, we're starting from this point right here. So how would I get those points to happen? What's the rise now? It's now 1. So I'm going to go down 1 and over 3. Like this. So if I do that, what would that point be?
0, 1.
0, 1. Is that the only one I could do? No, you could keep going. You could go down 1 again and over 3. Down 1 over 3. You can also go up 1 and left 3 like this. You can go in either direction, either to the left or to the right, as long as you mimic that slope. It's negative, so it's falling. but your increase in the y is just 1, and then you're going over 2.
So we have to use the point that's out in space all the time to figure
Yeah,
out.
they gave you, the only reason they give you that original line that's already drawn is to find the original slope. And then you base your answer on the other point. Okay? So again, you can choose any of those red points for the perpendicular, any of the blue for the parallel. Questions on that? Right, let me switch.
Question for the next one.
Okay, well, hold on, let me switch colors. Alright, so what's the slope of this line right here? We gotta find that first, or we have no basis for finding parallel versus perpendicular.
Maybe 3 over -3.
So you always have to do rise over run. So if we go from left to right, it's falling, right? How much is it falling? So negative, no, -3, and how much is it going over? So 4. So your slope would be -3 over 4. So it's falling, so it's negative. Alright, so I'm going to be starting from this point right here. I need to mimic the exact same slope to find the parallel. So it means I want to drop, how much?
3.
Drop 3, and then go over to the right 4. So 1, 2, 3, 1, 2, 3, 4. That's right here. What is that point? 1, -6.
So this one, I can't read the points. I can switch it up. I'm gonna say -6.
I know, it's weird because the slope does the reverse of writing the points. You just gotta be able to switch gears. Is that the only possibility? You could also go to the left 4 and up 3, which is kind of off the graph, so it's not ideal, but there are other points. Great, what about perpendicular? What would the perpendicular slope be?
4 over 3.
Positive 4 over 3. So now instead of dropping, I'm going to go up, right? It's positive, so I'm going to go up 4. 1, 2, 3, 4, and over 3.
Where's that on the y-axis?
No, it's not. That's the coincidence. Alright, so what's that point? 0, 1 again. That's a coincidence. It doesn't always end up there. And then you could keep going. Up 4, 1, 2, 3, 4, 1, 2, 3. You could also choose that point. You could also go in the other direction if you want to go over 3 and then down 4 to mimic the other direction. Fine too. Question about that? Yeah. So. Right, do the last one on your own, please. Ella. That's fine. The way that I did these examples, I should probably change them in the picture. Alright, so anybody have an option for the parallel point? Yes, Tara. Say it one more time. 4 or 5?
1, 2, 3, 4. Wait.
That's not what I have. I think they just might have counted wrong. 4 or 5 is not an option for the parallel. Did you guys get 4 or 5?
Yeah.
Maybe I'm counting wrong. Maybe I counted wrong. Hold on, let me look. Did you go up 2 and then over 1, 2, 3, 4, 5? So it's up 2 of 1. Oh no, you're right. I counted wrong. Sorry. You're right. It's 4 or 5. My bad. All right. What about the, and there are others, obviously, that was just the obvious one, starting from the point and then mimicking the slope. What about the perpendicular? Oscar?
1 -2, 1 -2.
1, -2, so the inverse would be -5/2. Get this. Cameron, did you have a question?
It doesn't matter if the word change, right?
What order? No, you should have the x value first and the y value second. That's how you write points. So yes, it does matter. All right. Other questions? That's pretty much it with this topic.
Really? For real? Dude, I wanna go.
Determining if the lines are parallel or perpendicular based on a picture or the equations, writing equations, and then this. All right. Any questions about that? So you guys do have plenty of time left in class, but before you start the homework, I'm going to pass out the previous quizzes, just so I don't forget. I'm going to pass out the day 1 and the day 2 quiz. You guys can take a look and ask me questions, and I'll collect them again, and then you guys can work on the homework and / or the graded assignment. Just give me 1 second. Very happy my technology did not mess up today.